All right, so the recording has already started. If I come here and please confirm if you can see my screen. Hello,
Yes,
can you
yes,
guys
yes,
hear
we
me?
can hear you.
Hello. Okay. All right, recap of what we did last time. Uh, we discussed basic configuration on FortiGate, and then we saw that how you need to configure the FortiGate based on the requirements that you have in the network. Once you get a brand new FortiGate, you'll be told to do the initial configuration of that. Right, so this concept will eventually become a little vast once we add more and more things, because for now the basic configuration actually means to pass the traffic through, assuming that you have a couple of networks behind. So you can sort of you can sort of take the idea about this by considering that I have uh, three VLANs, right? So I consider this is one of the departments in HR, and then I have one more. This is one of the departments in finance, right? And then one more. These are the marketing guys, right? They connect to the LAN, right? And when I say LAN, one switch is equal to one LAN, right? By default, as long as you don't have the VLANs configured. So it's an L2 switch here, and then this switch has this trunk were configured with the firewall, and then you have this internet router over here, right? The point is, this particular guy belongs to VLAN 10, this guy belongs to VLAN 20, this guy belongs to VLAN 30, right? So what we have discussed till now is that when you consider the initial configuration of a particular firewall, you always ponder on the four things. The first one was you configure the interfaces. So I'm going to come on the firewall and say that if this is port 2, this is port 1. So I'll configure this as router on a stick model and then get three SVI interfaces, which is the switch VLAN interfaces out of the port 2. So port 2 will have VLAN 10. It also will be having VLAN 20 and VLAN 30, and all of these three are the SVIs, right? This is sort of elected for these three pieces of department. So you will definitely need to have the three L2 VLANs over here. So you'll be having the VLAN 10 here, VLAN 12 here, sorry, 20, and VLAN 30. By the way, these are INT VLAN 10, INT, 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 right? So what you're gonna do is you're going to configure this as a trunk for the reason that whichever the traffic comes here needs to be tagged so that it can be allowed on the trunk. And the reason is, by default, only a single VLAN can be carried through the trunk. And which VLAN is that? Is one of the VLAN traffic which can go through the trunk without getting tagged. Which VLAN is that? It's a native VLAN, right? So I need to make it trunk so that it can tag the traffic that, okay, this comes from 10, this comes from 20, and this comes from 30. And likewise, you can configure the IP addressing here. Give IP to the HRS 10, 15, 255 dot maybe 2/24, and then this VLAN 10 over here becomes 10. It becomes 10.15.255.1. Likewise, the finance one becomes 10, 16, 255.20/24, and for that reason this one will become 10.15.255.1/20. So I'm putting 1 as the gateway, and likewise the marketing guys will be becoming 10.16.255.2/24, and then this SVI will be 10. Okay, this is 17.255.1/24. So this is sort of a lab that I had actually put on the group as well. So from the configuration point of view, you're configuring the interfaces, you're going to get these three SUIs out of the port 2, right? And then you also configure the port 1. And then the next part was you configure the DNS, right? And the third thing is you configure the static routing, making sure that your firewall is able to route the traffic, right? And then the last thing is you configure the policies, right? So these are the four minimalistic things that always would be needed there to route the traffic through the firewall. And this was the basic example of that. And for now, I had just one PC over here, but yeah, we have, I mean, you can have multiple PCs out there, and for that reason, you will be needing or creating the on the switch, right? Now, if I come here, all right. So today, what we are going to do is we will check that if I have if I have a PC over here which is connected on LAN, my firewall should be able to uh, give the IP address to that particular PC. So it's like configuring DHCP server on the firewall itself, right? So that will be the first thing. So we're going to discuss the configuration of DHCP server, DHCP server, and then the next one is uh, we're going to discuss configuration backups and revision numbers and administrators. Let me just write it down here. So if I come back here, so today what we're going to discuss is we'll try to configure one DHCP server on the firewall and ensure that whichever is connected behind the firewall will get an IP address automatically from the firewall itself. The next one would be backups and revision numbers. And the third thing will be types of administrators. All right, so starting first one, if I come back to the firewall first. Now what I'm gonna do here is I will just try to shut down. Let me check what is configured here first. All right, no VLANs for now. And if I come to the firewall, so firewall configuration is okay, have the IP for the port 2 only. So what I'm going to do here is I will just remove the configuration over here, keep it 0.0.0.0.0/0 and keep it undefined. Nothing needs to be on this one. I click on OK. So out of this port 2, I'm going to get three interfaces. I'll create VLAN 10 first. Let me call it I call it HR and the interface would be port 2. That is the parent interface for this. VLAN ID will be 10, and the IP would be 1015.255.1/24. Ping, HTTPS, SSH. Let me just enable that. Click on OK. So this is one of the interfaces that I have configured here. And the other one is going to be VLAN 20. I name it as finance. This is port 2. This is 20. 10 16.255.1/24 would be the IP address of this one. I'm going to assign the same things over here as well. I click on OK. This is the second interface that I have got out of port 2. And then the third one is going to be marketing. Okay, this is VLAN 30. I call it marketing. The interface, parent interface here is again port 2. The VLAN ID here is going to be 30. And the IP address is 1017.255.1/24. Ping, HTTPS, and SSH is allowed. I click on OK. Right. Now the point is, all these interfaces are actually acting as here now. Let me try to close this. Get my Epic pen here. All right, so the point is, it's the port 2 which has VLAN. So it's actually like INT VLAN 10, and then you have INT VLAN 20 and INT VLAN 30, right? It says IP 1015.255.1/24. This one is 1016.255.1/24, and the last one is 1017.255.1/24, right? Now, what I'm going to do here is I will just close this and then turn this switch off, get more two PCs over here. So VPC, so I get two VPCs over here. Connect this with the switch, and then get this one and connect this to the switch as well, right? Now, what I'm saying here is that this guy will be the HRPC, right? Its IP will be 1015.255.2/24. And the other one, which is this one, right? It's going to be the finance PC, and the IP address will be 1016.255.2. And the final one, which is the last PC, this guy is going to become the marketing PC over here, and it will be 1017.255.2, right? So let me just turn on the switch and turn on these PCs as well. So this is VLAN 10. This is VLAN 10, and the other one would be VLAN 20. And the last one would be This one is going to be VLAN 30, right? Now, what I'm going to do here is I come to the switch. I call it core switch. IC config T. Host name would be core switch. Click on N. Now, look at here now. So, uh, if I do show INT stats, I could see that this particular interface to which this PC is connected is gigabit Ethernet 0/2, right? And the other one is 0/1, and the third one is 0/3. So now that I'm saying that they need to be part of the VLANs now, because I have multiple departments and I want to sort of segregate the network. So it's actually called segmentation, and here you basically do the segmentation with the help of VLANs. I'm breaking the VLAN traffic, right? Now what I'm going to do here is I will just create the VLANs first. I create VLAN 10. I put the description. Okay, name. I name it HR, right? And then I create one more VLAN, VLAN 20. I name it finance. Then I create one more VLAN. It's VLAN 30. And then I name it as well. I name it as marketing, right? Now these three VLANs are created. So I'm going to do show VLAN brief. So I would say I got three VLANs and none of the ports actually is assigned to those three VLANs, right? So based on the topology and the requirement that I have, what I'm going to do here is I'll go to the Ethernet gigabit Ethernet 0/2 first. And I know that I need to put it in the VLAN 10. So I would say switch port mode access, switch port access VLAN 10, right? And I can put the description as well. I name it as HRPC or HRDPT, which says HR department. Now I end this, go back to the config T. The next port is INT gig 0/1, switch port mode access, switch port access VLAN 20 is the next one. And then I want to put the description on this as well. I say it belongs to the finance department. So I say finance DPT, and then I do exit INT gig 0/3, the third PC. I say switch port mode access, and then switch port access VLAN 30, and description would be marketing department. Right now, if I do show INT stats, gosh, show INT stats, I could see that there are three ports now, and these three ports are actually already part of the VLANs now. 0/1 is this guy. It has to be part of VLAN 20. So we're good with this one. The other one is HR department. And HR department is part of the VLAN 10. So we're good with this. And the third one is marketing department, and it's part of the VLAN 30, right? Now the point is, what should happen with this uplink, which is connecting me to the firewall now, right? So which are the traffic that comes from these access ports? They actually come from a particular VLAN. And for this guy to carry this traffic, it cannot do that unless and until you tag the traffic. And how you tag it, you sort of run a protocol, right? So I'm going to run a trunking protocol on this particular uplink now. I go to config T, I say INT gigabit 0/0 now, and I do switch port trunk encapsulation dot 1Q is the protocol that I'm going to run here, and then switch port mode trunk. Now if I do show INT trunk, so there you go. I'm allowing all the VLANs on this trunk for the reason that anything that comes tagged for any of the L3 machines or any of the access ports would be allowed on this trunk, right? And then the other ports, for example, uh, 0/2, 0/1, 0/3, they are part of the access VLAN. So if I do show int stats again on this switch, what I could do is I could come back to the config T. Oh man. So it started doing the domain lookup for this one, so I might need to wait. Okay. There was something, it shift alt 6. All right, works. Yeah, so I could do config T. Let me just remove the domain lookup here. I say no IP domain lookup. Okay, so it's not going to do the DNS lookups anymore. Anything that goes wrong will not be taken as a domain now. So yeah, the next thing is I want to put a description on this uplink now. So I do config T and int gig 0/0. I want to put the description here. I'll say uplink to FGT, and then I say end show int stats, show int stats, show int stats. Yeah, there you go. So 4 ports involved for this switch. The gigs 0/0 is the uplink to the FortiGate. The next one is finance department, HR department, and the marketing department, right? Now what I want is that all these machines, because for the lab it's just 3 PCs, but for the companies, right, there could be like 2,000, 3,000, 5,000 PCs. So what I basically want here is that all these PCs should get the IP addresses automatically, right? So let me come back to the VPC4 now to check if it has an IP address. So I do show IP. I could see it has no IP address. There is no gateway defined. It definitely has a MAC address because that is the hard-coded one. And if I come to this PC now, I want to do here IP config. There you go. So it already has an IP address. So what I want is that it should get an IP address automatically. So I do ncpa.cpl to open the adapters here. Go to the properties, IPv4 properties. And here I say that I want you to take the IP configuration automatically. So whosoever is a DHCP server, you get the IP addressing from that only, right? Now, everything is sorted behind the port 2. We have configured the VLANs on this switch. We have configured the PCs so that they can get the IP addresses automatically. Let me check the VPC5 as well to see if there is any garbage configuration over here as well. So I come here and then I do show IP. Yeah, so there is no IP over here. So we're good. Now let's get back to the firewall. So this is admin and this is 123 is the password that we have set. So let's check from the scratch. The first one was interface configuration. That's something that we have already done. Port 2 itself has no IP address, but the child interfaces, which are the sub interfaces from this port 2, they already have the IP addresses. VLAN 20 is 1016, 10 is 1015, marketing VLAN 30 is 1017. Let me check the DNS now. The DNS is also configured here. I could say latency of 10 milliseconds going to 1.1.1.1, which is the Cloudflare DNS. And the other one is Google DNS. And for this, I have the latency of 30 milliseconds. You guys might get the idea that Cloudflare is the fastest one. So possibly start using the Cloudflare one now. Uh, Now the other one was we also check the static routes. We already have the static routes over here. Anything that wants to go to the internet, which is 0.0.0.0/0, has the next handoff, which is the next hop 192.168.41.65, right? So good. Let me come back to the policies. Do I have the policies for this? I don't. I see a policy coming from port 2 to port 1, but that's not what I want. I want the policies from VLAN 10, 20, and 30. So let's configure the policies first. So I say HR to internet. The incoming interface would be 10. Outgoing is going to be port 1. Source, I'm going to keep it all for now. Destination, I'm going to keep it all for now. Service, I'm going to keep it all for now. And do you want to NAT it? The answer is yes, because the PC would be having the private IP address. So something needs to NAT it so that it can be routed on the internet, right? Now, this is one of the policies. Now, touching here one more concept, you can always copy the policies and you can paste them there as well. So I copied this policy over here, right? And I'm just right clicking on the same policy and then it says me whether you want to paste that policy above this policy or below this policy. So I say above, right? And it gets pasted disabled, making sure that it doesn't cause any conflict if you want to edit it. So I'm going to edit this, and this policy is actually for the finance one. So I name it as finance internet. Now this would become VLAN 20. Everything else remains same. Now I can enable this. So you go to right click on this policy, set stats. I'm going to enable this. And then I could copy the same policy. And now I want to paste it below this one. There's a logic why you want to paste the policies above and paste the policies below, but yeah, we're going to touch that once we discuss firewall policies in detail as a separate chapter. So for now, I edit this policy. So this would be marketing internet. Yeah, one more thing for you guys, that once you come here, there's this comment section. You can always put the ticket number here. So whenever there's a requirement, then HR people saying that they need internet access, they will always open a ticket with the L1 team, and then you basically put that ticket number here with the date as well. So let me, for the illustration, if I say that ticket number is this one, and then the date would be 7th of, okay, 6th of July 2025. I enable this policy right over here. Now click on OK, right? So we got the policies as well. So we're done with the 4 basic things. Now, what we want to add on top of it is that we want to make sure that all the PCs which are behind the firewall get the IP address from the firewall itself. So what's basically happening over here? uh, Clear the screen. Okay, click here now. So there is some guy, right? He's trying to do the discover process, right? And discover for the DHCP basically. So it's going to send the traffic, right? And the moment it starts broadcasting this traffic, it goes to this port 1. Port 1 itself belongs to VLAN 10. So this broadcast message will be running inside the VLAN 10 only, right? So that's how the broadcast also gets controlled with the help of the segmentation that you have done here. And here the segmentation is basically done by the concept of creating the virtual LANs, right? And likewise, the similar guy does the same thing, and this guy also is going to do the same thing. So all the broadcast traffic is going to run within the VLAN 10. For this, it's going to be VLAN 20. For this, it's going to be VLAN 30, right? It gets to the switch, right? And switch says that, okay, there is one of the trunks configured for me. And now that I am a switch, I just check the MAC address of this guy, right? So it says that for the discover message, the source IP is 0.0.0.0. Destination is 255.255.255.255, right? And the source MAC is going to be the species MAC. Let's say that it's AAAA. DMAC is going to be all Fs, right? So Since it's a switch, it only has the privileges to check the L2 information, which is this data link layer information. Based on that, it says that, okay, switch forwards based on the destination MAC address. It's a very important concept. How the switching happens. Switch forwards based on the destination MAC address, and switch learns based on source MAC address, right? So the moment this packet actually comes here, it's going to learn it, its source MAC, and then when it checks the destination MAC, why is it able to check the destination MAC is the reason that it's an L2 device, right? So anything that is up to the L2 layer will be checked, will be stripped off, and then you get to look into the all details of that particular packet at the L2 layer. And there you check the last destination, and then you say that, okay, this is the destination MAC address, and I have the capability of choosing this attribute and forward based on this. So when I say that it's all Fs, it means every interface will be sent. Every interface will be used to send it down. So it sends it down via all the interfaces except the one from which it actually gets this packet, right? So it's going to send this packet to this guy, and also this link, and then it reaches to the firewall. And on the firewall, it says that, okay, there is one guy that I'm actually trying to look for. Are you a DHCP server? It says yes, right? What are you looking for? I'm looking for an IP address. So there is how the discover happens first, and then you're being offered an IP address. And before offering the IP address, the firewall is actually going to ping the IP address, which is actually good, which it thinks that it could assign to this particular PC. Just give me 1 second. So once the IP address is being offered by the firewall, right? The IP address comes here. This guy is going to do the GR. It's like sending or pinging the same IP address, making sure that nobody in the network actually replies back. And the reason why you do the GR for here is you want to check the duplicacy. If you're getting a response, it means someone already has this IP address, and you're basically going to drop that particular offer. You don't accept it, right? But if nobody replies, then you just go ahead. You say that, okay, I'm just requesting for it. You can give me it, and then I'm going to send you an acknowledgement. That's how the door actually works, right? So that's what basically is happening here. Now the point is, I want to make sure that my firewall is acting as a DHCP server. So I come here for the VLAN 10. I'll get into this particular interface, and I want to configure this as a DHCP server. So here's the DHCP server, right? The moment I enable this, it keeps the details by itself. It's sort of an ease for me. So it says that, okay, DHCP starts is enabled. They want to disable it, I can. They want to enable it, yeah, I want to use it, and that's the reason I'm enabling this, right? It says that, okay, here's the range. This is the pool that would be used to assign the IP address to the LAN people, right? What's the net mask? This is the net mask, 255.255.255.0. What is the default gateway? It is the same as interface IP, because this guy would be getting the traffic, it's facing the LAN side. So for that reason, the IP address should be the IP address of the interface itself. So I'm going to keep it as it is. So whichever interface are you in, you're going to choose the same one as the default gateway for the LAN. What is the DNS server that you want to give these guys? Same as system DNS. What is the system DNS? If I want to check that, let me just duplicate this one here. The system DNS is 8.8.8.8 and 1.1.1. I'm good with this, right? What's the lease time? It's 604.800. I want to keep it 864.00. How much is that, by the way? Oh, 1 day in seconds. Okay, it's 864.00. Do I want to keep it 8 1 day only? All right, that's fine. Okay, the mode is server. I don't want to relay anything. I'm not configuring this particular interface, which is this particular interface of this firewall port 2 or the VLAN 10 inside this port 2 as DHCP relay. I myself want to act as the DHCP server. So we're not reading or studying the DHCP relay for now. So I'm going to act as DHCP server. The type is regular. We are not doing IPsec for now. NTP server, do you want to specify the NTP server? The answer is no. I don't want to play with the the NTP servers for now. Wireless control, I don't want to act as a wireless controller. Time zone, whatever is the time zone for my system, I want to give it. Next bootstrap is, do you want to sort of assign an IP address to this particular machine? And then when it boots using the same IP address. And then it sends the request to you so that you can assign the same IP address to this guy, right? Now, additional DHCP options, these are basically used for different purposes, right? Not going into those details for now, but yeah, just to give you an itty-bitty idea about this is that uh, when you're configuring the wireless on the FortiGates, right? When you have the wireless control on the FortiGate itself, uh, you can assign the DHCP options as well, where you can put the vendor assigned ID uh, within the DHCP option so that your request would be recognized by any of the wireless controllers around. So many DHCP options have many purpose, and you can basically put all those options over here, right? And then IP address assignment rules are basically the DHCP reservations. We're going to see this in a while, right? And yeah, that's pretty much about the DHCP. IP address assignment rules are is something that we'll be discussing right after we get the IP address for the species, and rest of the configuration is clear. Any questions till now before I click on OK here? Yeah, no questions? All right. So I've enabled the DHCP server. This is the IP pool. This is the net mask that will be assigned. This is the default gateway. It is the same IP of this interface itself. DNS server is same that's configured on this particular FortiGate. When it says system, it means the FortiGate itself. This is the release time. Mode would be server and not relay. I'm not relaying the information for now. Type is regular for or always. When we pick up IPsec, we might discuss IPsec one as well. NTP is which NTP you want to configure for this particular machine, which is actually trying to get the DHCP information. Wireless controls, we're not doing wireless controllers for now. Time zone, do you want to specify a time zone? I pick it up as whichever is configured for this system. Next bootstrap is, do you want to boot with already an existing IP address when the machine boots? Additional DHCP options means if you want to put any of the DHCP options, any of the informations, by the way, this is always written in the hex code, right? You put the values here, and then when all these values are basically given to the anyone who is looking for an IP address, all those options actually help you to determine the vendors. So that is the whole use case of vendor assigned ID. I guess it's option 41 or option 82, which actually finds use case in vendor assigned IDs. Likewise, you have the IP address assignment rules. These are the reservations. I can sort of say that I can create the IP address assignment rules saying that if there's a MAC address, right? Whenever you see this MAC address in the DHCP discover message, you always assign this particular IP address over here. Or whenever you see pick up this MAC address over here, you always block it. Or you always reserve the IP address for that one. So we're going to pick this up shortly. For now, I'm going to click on OK and then try to test it. So we are in, where are we? Which one is this? Okay, we are in VLAN 10 and VLAN 10 here is this guy. So what I'm gonna do here is I would see if this guy is able to get the IP address now. Yeah, something wrong. Uh, who's this one? This one is fine. This one is also fine. Let me just stop this, refresh this, and then turn this on again. Turn this on again. start. All right, looks like it's not booting. So what I will do here is I will come to the switch and write the memory here. So I'm just saving everything that's in the running configuration to the start of configuration. So that whichever the configuration that I have done here is not lost. Otherwise, when I turn this off, it's going to lose all the configuration. This is very important. Which are the configuration that you make on the switches or any of the routers, you make sure that you save the configuration before booting this that switch. So I'll just turn this off. Let me try if it's okay. It boots now. Start this again. Let me check first if the switch is back. Too many things happening. All right, let me check. So show INT stats. All right, everything seems intact. Now let me come back on this PC now. I wanted to show IP. There's no IP, so what I'm going to tell it, I configure this as IP DHCP, which is more like configuring this as the DHCP DHCP client. Okay, so it's doing DORA. I could see that there is one of the Discover messages that started shooting out, right? And then you have offer, and then you have request, and then you have acknowledgement, right? So this is the IP address that we actually got from this, right? So what's actually happening on the firewall? While all this was happening on the PC side, if I do admin, I do 123. I want to see what exactly is happening on the firewall. So what I'm going to do here is I will do debugs, diag debug, DHCP, DHCP. Okay, it's diag debug application DHCP S and then -1. Now what is this command basically doing? Diag debug means I want to diagnose. Diagnose means real-time communication, whatever is happening on the firewall. Debugging means I want to debug all that flow, whichever the real-time communication is happening on this firewall for an application. And when I say application, it means a process, right? And which what is the process in context? It's the DHCP process, which is taking care of all the DHCP things that actually happen with this firewall. And -1 basically says, give me all the possibilities of this firewall. Give me all the possible output of this particular service that's actually running on this firewall. So I'm going to click enter. And after this, what I want to do here is I do diag debug enable, right? So I'm just enabling. First, I set a filter saying that there is an application that's taking care of this DHCP stuff. I want to debug that. -1 says that I want to see all the possible outcomes. And then I say that just enable this, right? Now, what I'm going to do here is I will just come to the, where is it? It's here, right? I will just shut this down. Is there a shutdown command here? IP clear. All right, let me just reboot this. So I stop this. So it loses the IP as well because I have not saved anything on this PC. I want to force this DHCP process again to see what's happening on the firewall, right? So I come here, I start this again. I want to see what's happening here. Will I be able to boot it now? Refresh, start. Okay. Does it take a lot of time? Okay, there you go. So I open this one. Let me check if it has an IP address. It has no IP address because it just booted. And I want to force the DHCP now. I say that you're being configured, or you're being configured to get an IP address on the DHCP server. So it does DHCP. And what's happening here? A lot of traffic, right? Does it get an IP address? Yeah, so the DORA is complete. It has an IP address 10.15.255.2. Now let's check how did we actually reach to this particular one now. So I'm just debugging this. It says that leaving function with leave set. It just got this lease back. Now there's a discover message. It comes from 050796666804. And if I want to check this, it's the same guy, right? And it's coming from the VLAN 10 and it's an Ethernet port, right? So what it is basically doing here is it is trying to assign the IP address. So this is discover. The next one would be offer. Here it, before sending an offer, it's trying to send an ICMP echo to the same IP that it would be offering to this guy, making sure that this is not already being assigned to this one. And that's something that this DHCP server itself is doing. So the moment discover comes, DHCP server thinks that okay, there's a discover message. I'm supposed to send an offer to this to some guy, and the offer that I choose from my pool is something that I want to check first if it's already present in the network or not. And if it's present, I'm going to ping it, right? I'm going to ping it, and if it replies back, there that means it's already being assigned to somebody. And if it doesn't reply, which means it's uh it's not present in the network, so I can assign it to anyone, right? So there you go. You could see that I'm offering this particular IP address to the same guy. This is the DHCP offer, right? And what happened before the DHCP offer was ICMP ping, right? After this, this guy, once it gets the offer, right, it's also going to make sure that it does the gRP on its side. It also sort of tries to check the DHCP IP conflict. It also tries to ping the same IP address, broadcast the same IP address in the network, making sure that nobody replies. And if anyone replies, it means it's not going to accept it. And if nobody does, then it means it's going to request for this one. And what happens after that when you're requesting for it? Then the DHCP acknowledgement actually comes, right? So that's how this whole process actually happens, and this is how the IP address is basically getting assigned to this guy. Now the point is, I want to say that I'm not happy with this IP address dot two. I want to reserve an IP address here on this PC. So what I'm gonna do here is I will come back to this guy, and this is the DHCP server. I go to advanced. These are the IP address assignment rules. In Microsoft Word, they call it what do they call it? They call it DSCP reservation, but here they call it IP address assignment rule. So I'm going to create a new rule for here. I say that it's based on the MAC address, and the MAC address for here is the MAC address of this PC. So I'll come here and I'll just pick this one, Control C, Control V, And then I say, whenever you see a request from this, you always reserve an IP address 1015.255.100, right? And then I click on OK. So what would happen to this PC? Now I'm going to close this now. Now it's going to make a request. Will start now. Yeah, weird. Okay, there you go. It's back. So IP, let's check if it already has an IP. I do show IP. There is no IP address. If I come to the firewall, I say that whosoever has this MAC address should get an IP address 10.15.255.100 whenever it does the DHCP handshake. I click on OK. Now let's just try to test it. So let me come back here now and I do IP DHCP. There you go. The DORA is there. It should get an IP address and it gets the IP address 10.15.255.100. That's something that you have already reserved on the firewall. So this is how it actually works, and you could see the similar debugs on the firewall for this one. I'll leave that to you guys to see what exactly happens in the debugs when you have configured the DHCP reservation. And not just this, one more thing would be uh, so a couple of things. The first one would be you guys go through the DORA process again, right? After discover, there is this ICMP happening on the server, and then it goes ahead with the offer. And when the client gets the offer, it's going to request for the IP address, but before that, it also does the GR, or some people call it probe, R probe. Although these are two different things, you guys find the difference. What is the difference between these two? And then it requests for it, and then you get the acknowledgement, right? These are the things, and GRP and RPROB is something that is very important from this point of view. And then also make sure that you block a MAC address from getting an IP address. All right, any questions? And make sure, yeah, you do the similar stuff for these two guys. The VLAN 20 and VLAN 30. They also should get the IP address. And you can create the DHCP reservations or the IP address assignment rules for these two as well. Any questions? Please go ahead. Guys, can you hear me?
Yes, I can help.
Any questions, Haran?
Oh no, all good, right? I have
All
to
right.
revise the previous lectures, so I can recall after that.
Okay. Okay.